Hello, good evening, everybody. I'd like to hear your voice. If you're getting me speaking, please just respond and say good evening.
Good evening, sir.
Thank you very
Sir.
much. Thank you very much. That means,
Good evening.
okay, thank you. Welcome back again. Thank you very much for joining this free webinar. For the new workshop participants who have joined today, I would like to introduce myself. I am Mr. Christopher Kalolo, famously known as Mwalimu Kalolo, a lecturer at the Eastern Africa Statistical Training Center. I am the one who is facilitating this workshop, and I believe that when we come to the end of this workshop, you will be accumulated enough skills on how Git can help you collaborate, uh, track your projects, both locally and online, but how you can participate or collaborate with your team and how you can manage your workflows. So last week we started by introducing you to Git basics or foundational skills on Git. So we saw the basic commands, and not only that we saw, but we had the time to practice each and every command that we explained. And therefore today, by the grace of God, we will be discussing about Git branching, merging, and the collaborations. So this is very important for a person. You might be a statistical analyst, as we said last week, or a software developer. You might be a mathematician, whichever you are. But I believe that in the end, after we are done with this session, you will have accumulated enough skills that will help you work independently and with a team by using Git to track your files, to manage your workflows, but also to collaborate. So we will start with the branching. We'll start with the branching and see what is a branch and how do we create branches, how do we manipulate branches, how do we delete, how do we rename, etc., etc. So technically, when we speak about a branch in Git, a branch in Git is just a pointer to a commit. We say it is a movable pointer because every time you make a commit, then a pointer will move from the last commit to a new commit within that particular branch. So we are saying it's a kind of a movable pointer to a commit. Since we said that Git tracks your changes, tracks your new files and your deleted files, that doesn't mean that every time you create a branch or you make revisions, you make modifications, Git will be creating new files, maybe duplicating these files so that you can be able to control your versions. But rather, Git uh, just it doesn't create copies. Git doesn't create copies, but it just makes pointers. So when you commit your work, the branch pointer moves forward automatically. Moves forward automatically. All right, guys. I'm fixing something here. Okay. Okay, I was fixing something. Working from home has a lot of disturbances. So now, how does the branching look like? Because you see, when you're creating branches, it's like creating time machines. So you have this path and that path and that path with history alongside those paths. So you will have points in each line or the time machine analog that I'm using. You'll have points, and these points are the commits that we were talking about. They are snapshots, as we said last time. Now, for example, you have a branch called the main in your Git repository, and then you make a commit, and let's say the ID to that commit is called A, and then you make another commit B, and then you make another commit C. And then after committing at point C, then you decide to create a branch called the feature login. And after you've created a branch feature login, you uh, you move to that particular branch. You switch to that particular branch, and then you make another commit E, and then you make another commit F, and then you switch back to main, and then you make some changes in another commit D. So this is a graphical representation of how your branching history looks like in your repository. And we will see when we demonstrate it practically. So the key insight in this is that both branches shares commits. For example, you see we have branch main and branch feature login. They share commit A, B, and C. So A, B, and C are commits shared by both branches. So there is no duplication. But there is a divergence which we call it a fork point. eh? Now that divergence specifically starts new commits per branch. So you will see that feature login has its own commits E and F, while main has another new commit D. And these two commits, I mean these two paths with commits that does not are not shareable between these two branches. So what do we say that at that particular fork point, the work diverges. Git diverges the work between the main branch and the feature login branch. So each branch will grow by its own. It will evolve independently, and then in the end, we will bring together these commits eh, by merging. So Git has a feature called Git merge, which allows us to combine multiple commits from different branches, and we will be able to see that particular line of work after we are done with this particular theory here. So when you switch between branches, switching between branches changes the files in your working folder to match the branch's state. So, for example, you were on a branch main, and in a branch main you created a file called a.txt, or okay, you created a file called about.txt, for example, and then you created another file called home.txt, and then you created a branch and switched it to another branch called contacts, for example, and then you create a file called contact.txt. At that particular moment, if you commit the contact.txt, after that you have committed A, B, and C, technically, main is not able to see contact.txt. And then you might switch back to main and create another file, say, uh, whatever you call it, help.txt, and then you make those changes inside that file, and then you commit. So when you are on main, you'll be able to see home, about, and the help.txt, but you won't be able to see the contact.txt. But again, when you switch to features, I mean uh, to contact branch, you'll be able to see home.txt, about.txt, and contact.txt, but you won't see the help.txt because it was created outside that particular branch. So when we say switching branches changes the files in your folder to match the branches state, that is what we mean. So branching, that is number one. That when you switch between branches, the folder contents changes depending on that particular branch state. Number two, why this practice matters is because branching helps you work on multiple features simultaneously without causing interference, without causing conflicts. You see that? Because, for example, when you're working in a code project, you are writing a software, for example, you will have you will you will technically have bugs, for example, errors in code. And sometimes you don't want to cause these errors to propagate throughout your entire project. So you might want to fix these errors by using a particular branch so that the main code base is not affected. So you can work on multiple features. You want to create a login page, and then after the login page is functionally working, then you say, okay, because it's functionally working now, I can merge this code into the main code base. So we say main always stays stable. So when you are working with your project, remember you have a main branch. And I said last week that the old fashioned uses master branch is the same with the main branch. You see, the old fashioned is now discouraged because it looks like slavery. So because we're fighting slavery, then okay, let us rename it to main instead of using master. So if your Git still recognizes master as the main branch, you may rename it back to main, or you might be using the old version of Git. So branches that exist in Git, actually, when we say types of branches, this is true conceptually because these branches, we are the one that defines them. So you can have a main branch or a master branch, which is the main code base. This is the code base that will go into production. See that? So you don't touch the main branch. Always you make the main branch intact. You don't do nothing with the main branch. And then you can have the development branch. You see, for those programmers, they understand that we have development environment, we have production environment. So while you are developing, you might consider having a branch for development, so that when everything is functioning correctly, then you can merge the code base in the development environment back to the main code base. But you can have feature branches. Feature branches are useful when you are developing specific features in your project. Say, for example, you are you are writing a software. It might be a mobile software, it might be a web application software, whatever. But now you see that particular software has got different features. It might have a feature, for example, for logging into the main system. You might have a feature, for example, for making a purchase. You might have a feature for chat. You might have a feature for retrieving products from the database, etc. And therefore, you want to make sure that when you are developing any particular feature, you want to have its dedicated branch, so that when you are done developing that feature, then you will make that code, yeah, that code, the feature code back to development, and therefore after that you might delete that particular feature. But also we have bug fixes, because as a developer, or you're a statistical analyst, you're a data analyst, you're a data scientist, you're a data engineer, whoever you are, we understand that when we are writing this type of code, for example, if you're a software developer, you will encounter bugs every time. A good developer is not the one who doesn't encounter bugs, but the one who knows how to debug their code. So you will encounter bugs most of the time. And therefore, uh, because you will encounter bugs, you might want to make sure that you fix those bugs into a different branch that is dedicated for fixing a bug, because during the process of fixing bugs, you might cause other bugs, and you don't want these bugs to propagate into your main code base, and therefore you might want to have a different branch to deal with bugs. And when you have fixed them, then you move the code back to the code base. But sometimes after you are done with your project, and you see that this project now is well and good, it can go to the production whatsoever, then you can have release branches, and therefore you can have version 1, version 2, version 3, version 4, whatsoever. Hotfix branches, uh, these kind of branches, this is just a concept, but these branches which technically helps you to dispatch fixes. For example, you have a patch on security, so you want to release a patch so that you can fix a security issue and whatsoever. You can have hotfix branches for that. But sometimes you want to experiment different topics, different subjects you want to explore, and you don't want to affect the main code base. You might think of having experimental branches. Now, why do we group these branches this way? Sometimes we are doing this for clarity. This is why when we create these branches, we will prefix with a particular type. For example, when you're talking about uh, leaving main and development, then you are going to feature branches and etc. etc. You might want to create a branch by prefixing feature. So you say feature slash view results. This means your branch view results is part of the feature branches. So other features will come. Maybe you are creating a login page, and you might want to create a branch called the feature slash login, etc., etc., etc. Yes. So that's all about these types of branches. All branches we say are equal in Git, so there is no difference. Uh, and I said these branch types are conventions to improve collaboration. So you can you can technically create a branch and make it, I mean, name it whatsoever you want. But when we say these are conventions, that means we have a common way of doing things as maybe programmers, software engineers, data engineers, whatsoever. Yeah. We do that for clarity, to improve collaboration, because every time someone sees a branch is called dev, they understand that this is a development branch and not a main branch. They understand that. So it improves clarity as well. The prefixes, as I said, they are option. They are not mandatory, but we recommend them because they isolate branches. So it is easy for you to understand, to know that these branches are feature branches and not bug fixes. You understand that very quickly. Eh? So we are saying they are not mandatory, but they are recommended. When you complete your work on a branch, it is typically merged back to development or main, depending on the purpose or the point of your production or the point of your development. So you might want to merge them back to development branch or the main branch. Now, after I have introduced branches to that junction, then let me start actually illustrating how we create these branches and how we can move between the branches and see how these commits and stuff, you know, appears when we do everything with the branches. When we move between one branch to the other, when we commit to this branch and commit to that branch, and how we make them back and blah blah, etc. etc. Now back to square one. Thank you for joining. Thank you for joining. So I think you should get your computer ready because we are about to start doing whatever we wanted to do. I will delete all these files. I'll delete all these files. I think you remember the git ignore file. You remember, so you don't delete that. I am deleting these files and I will start afresh. I am not sure I'm deleting these files in where am I? Let me look for the branch I'm in, git status. Okay, git status, it says you're on a branch dev. So, okay, if I'm on a branch dev, let me git add the changes to the staging area, then git commit -m deleted files. And then, okay, we're good to go. So if we git status now, sorry, git status, it says on the branch dev, nothing to commit. Working tree clean, git switch main. Okay, clear, git switch main. Okay, the files are still there because now we deleted the files on git what? Git dev. So git merge dev, sorry, git merge dev. So the files are also deleted here. I will show you all this stuff. Then git status. Okay. So as you can see, we have deleted all the files because I wanted to make sure that we start afresh. So now git ignore, we make sure that what is remaining there is just the readme file, I mean the git ignore file itself. But on our working directory, we have the uploads folder. You remember we kept the git keep as a placeholder. We have the git ignore and then we have the readme.markdown. Okay, so what I want to do now, I want to start explaining how we can create branches. Sorry, let me do something quickly. Okay. Now let us start now. So we are asked here, I don't know which ID you are using, but we are asked here that we have to do something according to our presentation slides. The hands-on says create a bio.txt file on main, create a branch called feature contact info, and add a new file contact.txt with contact info. And then commit the changes in that branch, and then git switch branches. Okay, so What I want you to do is to perform these four tasks here. We will perform together because I'm going to show you how we can create a branch, and we will use three methods or four methods to say to create a branch. So we have two methods. The first one is Git branch checkout. Uh, Sorry, the first one is Git branch and then the branch name. The second one is Git checkout minus B or hyphen B and then the branch name. The third one is Git switch minus C and then the branch name. I will explain what each of these means. We will start by the Git branch and then the branch name, and then we will continue. Now let us go because you are required to create a bio.txt file on main. So first we must make sure that we are on the main branch. We are on the main branch. Oh my goodness. Okay. So if I check, you can continue using the Git bash terminal that we were using last week. Make sure that you have navigated to the track the Git the Git repo actually, or the project that is tracked by Git. Make sure that you have navigated inside that particular directory. For example, my my repo is Git workshop. This is the working directory which is tracked by Git, and I have made sure that I am inside that particular folder. Then what I do, I create a file and I call it something.txt and I put some content. So maybe I say touch bio.txt. Okay, okay, the touch. Okay, this is not. This is terminal. Let me use the PowerShell. Sorry, let me use the PowerShell so that I can mimic the button to edit area. Toggle kill terminal. Let me kill terminal and go direct to the PowerShell. Okay, terminal, the PowerShell. Okay, I want to write commands the same way they will be done in the Unix environment. I'm used to the Unix environment, so I'm sure that I must do that. So let me do the git bash here. I would rather, okay, I'll be using git bash instead of. So we are on Git workshop as usual, and as you can see, we are on the main branch. Uh, so we are we are creating a file. I'm creating a file oh, called bio.txt. I'm sorry, my computer. Okay, touch bio.txt. Okay, the file is already created. So if I go back to my ID, I will be able to see bio.txt created here. And I want to put some information. So I will say maybe basic info. Now you write your your bio. So okay, let me write Christopher Caloro is a lecturer of e-learning institution in Tanzania. Tanzania. He works. Okay, not able to see these tokens. Okay, in Tanzania. He works as an instructor in the areas of data engineering, software engineering, machine learning engineering, oops, and statistics. He currently that's so this is my file. I think you have created your own file. You don't need to copy nothing from mine. This is my file. And if we go to our slides, what does it say? It says after you have created the file on a bio.txt on main, then create a branch called feature.contactinfo. And then, so what I will do, after we have created the file, you remember what do we do? We create a file like this, and then we don't only create, but then after we have created the file, what do we do is to make sure that the file is added to the staging area. The changes are added to the staging area. And therefore, we might want to check the status of our deposit of our branch, and then the status of our branch says untracked files. We are on a branch main, and then we have untracked files. So we use git add to add the file. So we will say git add and then bio.txt. You remember that, and then let us commit git commit, and then write the message. Uh, my bio information, and then we commit, and then everything is done. Now, after we've done that, we can check our status again. Uh, the working tree is clean. After that, what did we say? We create a new branch. Now, how do we create a new branch? Number one, we create a new branch by writing git, then branch, and then the branch name. So our branch name is feature slash contact info. That is the only way you can create a branch. Git branch feature contact info. The branch is already created. So if we want to see the branches that you have up to now, what you do is just say git branch. The command git branch will list all the branches that are in your working repository. So you see After Git branch, it says feature slash contact info, and the other is main. If you look closely, you will find that main has got a different color, but also it starts with an asterisk. That particular asterisk behind main, it shows that main is the head branch. In other words, that we are currently on the main branch. If we switch to the feature slash contact info branch, then that asterisk will go to the feature slash contact info to indicate or to show us that the head branch is feature slash contact info. Now that the command for for listing branches. After we are done with listing the branches, now we are free to actually to switch to that particular branch. Now switching to a branch, a command is git, then just write the word switch, and then write the branch name. So the branch name is feature slash contact underscore info. If we click, it says switch it to branch feature underscore, feature slash contact underscore info. And you can see it here that we are on feature contact info branch. And even if we say git branch again, you see now the pointer is on feature slash contact info. If we git status, it will tell us we are on feature slash contact info branch, on a branch feature slash contact info. See that? That is how you create and switch to a branch. Now, if you go back to our presentation slides, the presentation slides shows that we are required to create another file called contact.txt. Contact.txt. So let us go back to our terminal and write touch contact.txt. And let me, okay, touch contact.txt. If we git status, it shows that we have one untracked file, which is contact. You see, contact.txt. If we go back to main, if we git status, it still shows that there is a file called contact.txt which is not tracked. So where do we want to track this file is to the branch feature contact.info. So we need to add this file, git add contact. So before we add, let us make some changes. So if we go to our editor here, the files we see contact.txt, contact.info, contact.txt, so we can add some information. Contacts, so name, okay, Christopher Caloro, email at gmail.com, phone, maybe it's 255-715-522-441. So this is my my contact info, then our file is saved. Now, let me use a terminal here so that you will be seeing what is going on. You'll be seeing what is going on just right here. So remember when we created a branch called the feature slash contact info, we created it from a commit, and therefore the bio file was present. So here we are in contact. If we say git status here, you see we are where we are on a branch feature contact info, and we want to make sure that these information are committed, and therefore what we do is git add. And you remember, guys, I told you last time that if you have multiple files and you don't want to add them one by one, you might use a period to add all the files instead of adding a single file after the other. When you put a period, it means it will add all the changes in all the files. It will add all the files. So if we do that, then we have added, and then we git, we check what is in the staging area, and we see that the staging area contains a file called contacts.txt. So we are good to go. Let me clear the screen, and then we commit, git commit -m, and then committing a txt file, and then enter, then we are good to go. So right now, if we git status, it is clean. As you can see, git status show that we have a clean working tree, nothing to commit, everything is put in its place. But you remember these contacts.txt have been committed while on a branch what? On a branch contact info. Which means if I switch back to my main branch, then this particular file here, contact.txt, will not be seen. You will be watching while I'm writing. So we say to switch, you write git, then you write switch. But the old way also, which is also a way to switch between branches, is called checkout. So you might write switch, you might write checkout, and then main, because we want to go to the main branch. And then we are back to the main branch, and you see on my working directory here, the file contact.txt is missing. And this is because the snapshot was saved while on contact info branch. So if I go back to contact info branch, switch feature slash contact info, okay, contact underscore info, you'll find that the file reappears as it is seen there. Now let me go back to our notes or our presentation so that I don't go out of scope. Okay, so that is the fastest way to show you how to create a branch, how to move between branches. You can use switch, you can use checkout. Checkout is the old way, is an old-fashioned way. The new way is switch, but you'll find you can always choose between the two. But I think the checkout is kept for legacy purposes. Okay, another thing is that you can create a branch from a revision. From a revision. Now, what is a revision? A revision is an ID, is an identifier, that particular number which identifies this commit uh, or distinguishes this commit from that commit, from that commit, from that commit. So, in other words, those identifiers are called revisions. So you can also create a branch from what? From a revision. How do you see these IDs? We see these IDs by using either a history tracker. We last week we saw that if we write git log, then git log will give us the commit history of your work. And then in that commit history, you will see those IDs, which identifies or distinguishes one commit from the other commit. So when we say you can create a branch from a revision, for example, if you are writing a book, for example, now this is it's a story. We are trying to create an analog here. You are writing a book. Now you make sure that after every chapter of that particular book, you make a commit. So you finish chapter one, you make a commit. Then you write chapter two, you make a commit. You write chapter three, you make a commit. Blah blah blah. Chapter 20, you make a commit. And then later you think, why shouldn't I change the line of the story from chapter 5? Now, instead of copying the whole book and deleting chapter 6 to chapter 20 so that you can start with chapter 5, or instead of copying chapter 1 to chapter 5 into a new document and start writing chapter 6 going forward, eh? You don't do that. With Git, you don't do that. With Git, you just create a branch which will be pointing those new commits, the new direction. So you will start chapter 6, 7, etc., going into a very different direction. That is the power of branches. So you can create a branch from a commit or from a revision. And remember that it is easy for you to create a branch at a particular point. For example, you have written chapter 1 up to chapter 20. And then from 21 is where you want to have a different branch. When you create a branch at that particular juncture, you don't need to specify any revision or any particular commit. But at this juncture, you want to go to a specific chapter and start over. This is why we say we create that particular branch from a revision. You see, you have A, B, C, D, and that line is the main branch. And these A, B, C, and D are commits. Now, you choose a revision. For example, you say, I want to go to a particular revision, maybe uh, revision B. Then you will create directly from revision B. And that means that line will grow from A, B, and after B, it will branch to a different path. Now, there are different ways that we can use to create a branch from a particular revision. The first is to use the ID, or you can use the head pointer, because always you must remember that whenever you commit, the head pointer will move to the current commit. Now, this is syntax which says head and then epsilon, then you put a number there. It tells Git that please move back one step, two step, three step, four steps, five steps. 60 steps, etc. So if I say head and then one, that means go to the previous commit. If I put number two, that means go to the previous two commits and create a branch from there. Go to the previous three commits and create a branch from there. That is the power of creating branches from revisions. So that is the first step. Now the first step is to git log so that you can see you can see those revisions. And the second step is to create now. So remember the first time I usual the first time when I introduced creating branches, I told you that we have three ways, but I showed you only one way. And the way which I showed you was it was git branch and then branch what? Branch name. Now this is long because when you create a branch, yeah, then you want to make sure that you switch to that branch. So you have to create the first step and then to switch to that branch the second step. But we have a shortcut which creates and switches to the branch at the same time. So if we write, for example, git switch -c and then the branch name, it means create the branch called the branch name and then switch to that particular branch immediately. Alternatively, you can say git check out because I told you check out and switch, they both helps move the movement between branches. So if you write git switch and git checkout, they both work the same way. But now when you want to create and move to a branch, switch uses a flag C, -c. But checkout uses a flag -b and then branch name. So the latter is the old-fashioned way, and the former, that is switch. This is the modern way of doing things. So this is another way you create and switch at the same time. So let us see now. Now, since we are on the branch feature contact info, if we git log, we will see all these commits. So you have the commit saying commit. Oh, I'm sorry because now I have the old stuff in here. But I think we started from this commit here. So the commit was this commit here, my bioinformation. Our message was my bioinformation, and another commit was committing a .exe file. So before we go to that juncture, let me do something very quickly. What I want to do here, I want to show how we can let us make a few commits more. That's what I mean. So what I do, because we are on which branch is this? Git status. Okay, so let us go back to main. Git switch main. We're on main, on the main branch. And therefore, what do we do with the main branch? We see our bio here. I want to put some more information. So I'm saying he holds, okay, he holds a master's degree of science in data science from the University of Dar es Salaam. and currently pursuing a PhD at the People's University of Japan. Now, this is another is a modification, it's a change, which means if we git status here, sorry, git status. If we git status here, we'll find that bio.txt has been modified. So since it has been modified, what we do is we git add that particular file and then git commit, put a message and say uh, committing after changing, after modifying bio.txt. And at this juncture also, let us create another file. So we create it by using a Unix terminal emulator and call it help. So I put a message directory. So let me echo reach us for help by writing direct into our email. And then the file is called help.txt. We're good to go. So if we come here, we see the file help is right there with the content that we just wrote. And therefore we commit this as well. So git add help.txt and okay, we say git commit -m committing help for the first time. We're done. So if we git status, we'll find we are on branch main and nothing to commit the working tree screen. So if you see here, you have help, you have bio, all these files. And if we go to git log, let me reduce the number of lines here. You see that we have, okay, we have this, and this. So these commits, when we were deleting the files, just forget them. We told you that Git keeps track of everything. You see, this is what we started last week. So if you go, all the commits from last week, these were commits from last week, but now we are here. So for example, I want to create a new commit. I mean, I want to create a new branch from a revision. Now the revisions are these numbers. So these numbers are a short form of that long string. If we could just do git log like this, you see the long string. This is a very long string. See that? But now if we use git log and then one line graph, it provides a compact version of git log history. So you'll find that, for example, this is 9FFDD31, committing after modifying bio.txt. You will find it here. Committing after modifying bio.txt, and this is a string which ends with 6C0C7. So we are taking it here, committing 9FFDD31. So this is the revision. So we copy this one. After copying this one, if we create a branch from this commit here, that means the fork comes here, and this new branch will not start from this commit here, which is committing help for the first time. So we'll lose committing help for the first time because we want to start from committing after modifying bio. So next time when we move to that new branch, right? And then in that new branch, if we git log one line graph, we will see the final commit will be committing after modifying bio.txt. So let us give the name to our branch. I don't know which name we suggested here. Okay, there is no name, so let me quickly suggest a name. So for example, we will say git, then switch. Now I'm using that that shortcut which starts by creating a branch and then switching directly to that branch. So switch C, and then I put the branch name, and the branch name may be uh, revision, revision branch, so revision B, and then I put that revision. So if I click OK, so we have the revision branch. Revision, it has switched to a new branch called revision B. So if we git log and then graph here, what do we see? We see that the final one is committing after modifying bio.txt. And remember, uh, we have that direct stuff, and you see this the file has been deleted. That's why it is crossed here because it is not found on where? It is not found on my revision B. If I go back to main, you will find this not crossed as it is seen right away. So if we say git switch back to main, you'll see the file is restored. Git switch to revision B, the file is deleted because it is not available in this current what? In this current branch. And remember, it is not available because we created a new branch from a commit prior to creating this file. And this has made this file to not be available to the current what? To the current branch. So that is creating a branch from a revision. But however, that is one way. You copy that ID and then you make sure that it appears there. But another way, uh, let me show you another way. Okay, git switch main, git branch. Another way, I've got rid of that branch revision, so we don't have that branch anymore. Git branch. We see we only have two branches. That is fine. Okay, so another thing that we do here is what? Is showing you another way. So another way, as you can see, we said git, and then Git what? Git log, one line. I want to show you another way to create a branch from a commit. Now you see currently we are here. This is where the head pointer is pointing. So the head branch is main right now, where we have committing help for the first time. So I want to go back to my bio information and then I create a branch from there, which was our very first commit. What I do, I say git, then switch your checkout, C, and then revision the same way. So now maybe let me call revision K so that we don't confuse. And then instead of writing an ID for the revision, I'm moving the pointer. So head, and then I will specify the steps. How much do I want to go back? How many commits? If I put one, I will be going back to committing after modifying text. If I put two, it goes to my bio information. If I put three, it will go to deleted files. Four, merge branch dev. If I go to five, it will go to committing independent txt. To six, it will go to committing animal.txt. To seven, it will go to animal blah blah. To eight, it will go to committed info.txt. So if I put it eight here, what is happening? Uh, we are on revision K. So if we say git status, it says on a branch revision K. And if we say git log, one line, minus, minus, graph, you see we have adding my new file, illustrating using alias, committing changes from multiple files. This is my whatever, whatever. So I have gone to the commits that I made last week. I remember last week we have the book.txt, the new.txt, etc., etc. This is where I have gone that far. You can see that. So it is by specifying what? By specifying the number of commits to go back. So we have specified 8. So we have gone back 8 steps. Are we together? Let me get rid of this branch and then show you something again. Git branch. I want to delete this git branch. So let me git switch main. Git branch. Delete delete the revision K or revision git branch delete revision K. So we don't have that branch. Let me clear. So I want to create it again. Let us git log. Now we want to move to this commit here. I mean to this commit here, so that you can see all the deleted files. DCBCE, so we is 1, 2, 3, 4. So if we go 4 steps, so 4, you see all the files that has been deleted have been restored here. Because I went to a commit before I deleted the files. And you see all the files have been restored here, the animal.txt, the book, the independent.txt, the info, the new, and blah, blah. So all those new files are not found because We created those files later after this particular commit. So this is the power of creating a branch from a commit or from a revision. I think that is very well captured. And then we go again to another concept. Another concept. Hmm. This is creating branch from a revision, just showing you. Uh-huh. Then let us discuss about the head. What is the head? Because you saw me using head, and you saw when we log, you always find the word head there, and I told you head is a pointer. So head is just a pointer. Mhm. It points to where you are currently are. So when you move to a branch, the head pointer points to that particular branch. Actually, it points to the latest commit on the branch you are on. When you commit while you are on a particular branch, and then uh, Git log will show you the head pointer is on that particular commit, as we have seen. Yes, so that is all about the head pointer. I will show you on the simulated environment how it moves, right? And we have seen that you can move to different branches by using this command here. Even when we were creating branches from a particular commit, we use this syntax. I think I don't know the name of this, is epsilon or something like that. This character here between head and one. So head, and then you put this character here, and then you put a number which takes you to a particular commit. Now, when you go to a previous commit in the same branch, like you do using this command here, you will go to a state called a detached head. So when you do something like this, you can do git checkout head and then a number to specify the number of commits that you want to go back, or you can git checkout, switch and then head and the number to specify how many steps or how many commits you have to go the previous commits before your current commit. It puts you to the so-called detached head state. So, for example, you have deleted files. You want to restore whatever changes that you have made. You want to restore your history. Sometimes you can move by using Git reset. So we'll discuss about Git reset later. But here I wanted to tell you about the head. The head and the command to move between different commits, going to the previous commits. So I told you that this takes you and puts you in a condition called, or a state called, a detached head. Now I understand that some of you guys, you might be struggling running these commands while on your computer. So I want to show you a few things. I will use a simulated environment to show you how all these commands works before we go to the next procedure of merging, rebasing, and then tracking remote files. So as I said, a detached head is a state where the head points to a commit, not a branch. That is called a detached head. So for example, if I come into my working environment here, Let me see where am I? Okay, I'm on Git main. So let me Git branch to see the number of branches we are in. Okay, I'm not on main. I'm on revision K. So if I say Git, for example, and then switch and then say head and then say something like 2. You see, it will tell me that I'm on a detached what? Detached head. So if I do something like this, sorry, uh, okay, a branch is expected. I think I got it wrong. Let me revisit it quickly. Okay, it is something like uh, what did I do here? What did I do? Responding. Let me use this terminal here. Clear, git, branch. Okay, I'm on revision. Okay, so git, switch, uh, head one, for example. We haven't committed git status. Okay, git, switch main, git status, git log. Okay, git log, git log. So I'm here committing help for the first time. So I expect if I say git check out head one. You see, I am on the so-called detached head. You are in detached head state. This here. You can look around, make experimental changes and commit them, and you can discard any commits you make in this state without impacting any branches by switching back to a branch. So right now we are on, if I say git status here, let us clear first. I say git status. It will say we are what? Head detached. So we are detached. So we are in a detached head state right here. We are not on any branch. If we say Git branch here, you will see that no pointer is pointing to nothing. The head pointer is pointing to nothing. So you see the branches are feature, main, and revision K. But since we are on a detached head state, it says head detached at that. So we can do anything we want here. We can experiment, we can commit, we can do whatever. But if we want to save those changes, we must now create maybe a new branch and then have those changes stored at a temporary branch. Otherwise, we are going to lose them. So that state is called the detached head state. The detached head state. Okay. Okay. Now I will show you all this stuff before we go to other commands. Let me show you something very important. Please open your browser and in your browser, what I want you to do I want you to write this on your search engine. So at the Google search engine, just write Git playground, for example. So I will show you a few things with Git playground where you can practice your commands. We have a lot of simulated environment, but today I will use these two. So the Git branching, especially the first one, but also the second one, which is the Git playground. If you come to the Git playground here, you will have a simulated environment where you can write your commands. You see, this is a Git cheat sheet. It gives you everything that you want to do here. So for example, before you start anything you want to do, you cannot say Git status because at this juncture you haven't initialized your repository. So it will say not a Git repository. Run Git init first. So Git init. This is a simulated environment on the browser. Git init. Then you can say Git status. It says untracked readme, so blah blah, and then Git add whatever. Bam. Git status now. It will tell you that everything is fine, and then you can say Git commit. Uh, Everything is fine. I didn't put any message. Git help. You see, you will have all those information that tells you which command does what here. Git help. So this is a simulated environment. It gives you several commands, and you can even, if say Git branch for the list creates and deletes branches, so you can click at this particular arrow, and it shows you the possible commands. So you see usage, Git branch name, then delete. You can delete by adding the delete flag. Git branch feature login. You are creating a new branch, etc., etc. Git checkout and Git switch does the same thing. Git branch minus d deletes. Git merge, we are yet to discuss about Git merge or rebasing. We will discuss later. But what I'm showing you here is that this is a simulated environment. You can run your Git commands here. This is called the gitmaster.me/playground. But also we have this now, which I love the most. It is called learnGitBranching.jes.org. So here it gives you the welcome information. When you click the tick, it gives you this screen, which you can always find by clicking the question mark here. So what does it do? It gives you levels. For example, now you have these, you see, because I have played already with these levels, it shows that I have mastered them. So it still have these. So for example, number one, you want to go for level one, which says introduction to Git commits. So if you click Git commits, then it tells you about Git commits. This is the very useful information for you. It says a commit in a Git repository records a snapshot of all the tracked files in your directory, and the other information is given there. If you click next, then it shows you that the command is, if you hit that command, the screen shows whatever it's going on. If you click another time and another time, so click next until you go to a place where you can practice now. So it says go ahead and try it out on your own. Yes. So it will give you the goal. The goal now is what? The goal now is for you to be able to make two commits. If you make two commits, uh, the first you are on Git branch main. So the head pointer is pointing on main. But the goal is to make sure that you commit to a point where the head pointer will be pointing to where? To C3, from C1. So the head pointer is pointing to C1, or the current commit is C1, and you are required to make other commits so that your head pointer will be committing to C3, will be pointing to C3 as a commit. So whatever, when you are done with your exercise, if you have successful uh, done whatever you have been asked to, then you will be told that the problem has been solved. That means you have successfully solved the problem. So whatever you do here, you will be able to see graphically here. If I say git, for example, git and then commit, you see, it moves. So I have one more commit to make. I say git, commit, I'm done. And it says solved. So I am done solving it. It says, great job, you solved the level in 2 commands. Our solution uses 2 commands. Awesome. You made our solution. Would you like to move to the branching in Git, the next level? Remember, today we are doing branching in Git. So if we say confirm, what happens now, it will give you information about the Git branches and stuff, and then you just click these next until the end, and then you will be required now to do the stuff yourself. Okay, so uh, you see, you are required to create. You are required to create another branch called bug fix, and then switch to bug fix. That is the meaning. Currently, you are on commit C1 and you are on a branch main. What the goal says, you have to make sure that you are still on commit C1, but you are on a different branch called the bug fix. How do they rank you? They rank you depending on the number of movements you make. For example, here, in order for you to be ranked high, you must make only 2 movements. Only 2 movements. So if you want to know, you come to instructions. If you click instructions, you are good to go. So they will tell you the instruction. Oh, you are all ready to, when this will close, make a new branch named bug fix and switch to that branch. By the way, here is the shortcut. If you want to create a new branch and check it out at the same time, you can simply type checkout to be your branch name. So actually, for you to be ranked even higher, you need to just make a single move. So if you say git checkout, or like I said, git switch -c, and then bug fix as they name it, bam. You see, a single move has solved the puzzle, and says you solved the level in 1 command. Our solution uses 2. Our sum, you exceeded our solution. So, brothers and sisters, this is where you can practice your commands at the same time visualizing what happens at the background or in the background, whatever you can say. Then you go to merging and blah blah, all these commands. So because I haven't explained anything about merging, I won't show you anything here. But what I want to say, that this is your safe place to practice your Git commands. You get acquainted with different commands and terminologies and stuff. You'll be able to see what is happening at the background. Wherever you write a Git command, what happens really on the background, what happens, you are able to visualize it. So I'm saying this is a very important platform for you. Make use of it. Make use of it until when you get acquainted with the Git commands, you will flow effortlessly when you are writing your projects. Now back to square one. Back to square one. Uh, so we have 6 minutes before we wind up. I will try my best to make sure that we do only what is supposed to be done within these 6 minutes. Now, sometimes you can delete a file. I mean, you can delete a branch, or you may want to rename it. So let me explain two more or three at least, uh, three three commands that you usually will have to use them as you work on your project. Number one is renaming branches, because sometimes you have a branch and maybe you made a mistake naming them, and you want to make sure that that name is modified or rectified. How do you do that? So if you want to rename a branch in Git, if you want to rename a branch in Git, for example, instead of revision K, maybe we wanted the name of the branch to be revision. So let us go first to main, switch main. Git. So, Git switch revision K. Now we are on revision K. If we want to rename revision K, what do? We just write Git branch minus M. Git branch minus M. Since we are renaming the current branch, so we say Git branch minus M, and then instead of revision, we want it to read rev. So if click enter, then our branch will be renamed to rev. If we say git branch, we see we have feature, contact info, main, and then rev. But sometimes you want to rename a branch that is not the current branch. For example, we are on rev, but you want to rename feature slash contact info to contact. So we will say git branch minus M, and then the old name, which is feature slash contact underscore info, to a new name, contact. Then we will have renamed a branch that is onto the current branch or the head branch. If we say git then branch to see the list of branches now, we now have rev, main, and contact. These two methods are used to rename branches depending on which branch are you renaming and where are you currently. And then another thing is deleting branches, because if we can rename branches, we also can delete branches. So when you want to delete a branch, first you must be out of that branch. For example, we cannot delete a branch called rev if we are inside rev. But deleting branches is done by using git and then uh, you branch name git. Sorry, sorry. We use git branch. I see git, no, yes, git branch and then d, like this one, git branch, and then we'll say minus delete, and then the branch name. Now At this juncture, we are not able to delete this branch because we are inside the same branch. If we run, it says cannot delete branch rev used by work tree at blah blah blah, which means we must first go out of this particular branch. So we'll say git switch and then maybe we go to main. After going to main, then we are able to now delete the branch. So if we say git branch, you can see these branches again. And then git, now we are on main. You can see that asterisk symbol is on main. We're on main, then git branch, then hyphen hyphen delete. Now, instead of writing hyphen hyphen delete, you can write a shortcut to that which is called minus D. Minus D is the same as writing minus minus delete. So they work the same way. That is the format, the shortcut. So if you say git branch minus D and then the branch name, for example, the branch is rev, now we are able to delete. So deleted branch rev, which was on that particular commit. If we say git branch now, we only have contact and main. Now, another thing which is very important is when you have unmerged changes or unmerged commits, we say unmerged commits. For example, if we go to git and then contact, because you cannot delete the main branch. So git contact, git switch contact, and we are on contact, then we want to make sure that we add some contacts here. So it was email, name, phone, and then maybe we want to put an Instagram handle. We'll say an Instagram handle. For example, I don't know whether I have an Instagram account, but if we say something like Christopher Carol, maybe we have made a change. And after making that particular change, we git add contact.txt, and then we git commit minus m, and then say Instagram handle, right? Yeah. So if we go to git switch main, because we want to be able to delete that particular branch. So we're on git main branch. If we say git and then branch and then delete and then contact, then we want to be able to delete that particular branch right now. And the reason is because we have unmerged commits. So if we click enter, it says, sorry. I included a character which is not recognized. This is delete and then contact. The name of the branch is contact. If we hit enter, it says error. The branch contact is not fully merged. If you are sure you want to delete it, you have to force the delete. Now, how do we force the delete? We say, okay, even though we do have unmerged commits, but we want to delete it anyway. So we must tell Git that we don't care. How do we tell Git that we don't care? We say delete minus minus force and then contact. Now, this is the correct way, but however, we have a shortcut to delete to these two flags minus minus delete minus minus force. Instead of writing all those long characters, we can just write minus capital D. So remember the common delete, the shortcut flag is minus small d. But if we want to force the delete, despite the fact that actually we have unmerged commits, but you want to delete it anyway, then you use the delete force or the hard delete. We call it the hard delete. You have the soft delete and then you have the hard delete, and this is the hard delete. which forces this branch to be deleted, despite the fact that we have unmerged commits. If I if I click enter, if I hit enter, then the branch will be gone. Bam, deleted the branch contact. So if we say git branch, then the branch is gone. So we are remaining with main. So okay, we have deleted. What are we going to do? Maybe we have deleted accidentally and we want those changes or those modifications that were done on that particular branch. What are we going to do? Then, in order for us to be able to do that, we can check. If we say git log and then one line, it will give us the history. It might fail to give the the details of what, of the delete. So you see the deleted commits will not be found by using git log. Do you see? We don't have the details of the delete because we're using git log. So if we want to find out even the commits eh, which the branches has been deleted, we use git reflog. So if we say git reflog, now we are able even to see everything that has been deleted. So you see that? We deleted contact. I think it was contact. We switched it to main. We have the Instagram handle commit. We switched it between main and contact and blah blah. So we might say because the between the deleting of that particular branch, we are only one commit away. So we understand that we can restore that particular history. How do we do that? So you see, for example, this one here is pointing to main. Maybe we want to come back here, or maybe we want to go to the previous commit. So what we will do, we want to restore that file. Okay, so okay, git checkout -b, and then we want to call that particular branch. Maybe it was rev, and maybe it was contact, and I want to call it contact again. And we say head, and then one. Want to go back to switch it to a new branch called contact. I think we didn't hit that. So I made git checkout -b. Then let us call it cont. Maybe let me put a head, particularly 3, for example. See whether we can recover the lost commit. Okay, now you can see that we have gone very far. Actually, what we want here is clear git switch main git reflog. Okay, want to go back here. Want to go back to the Instagram handle. You remember the Instagram handle. So I'm going to take this ref and I will say git checkout -b contact 2 or contact 1, and then put that particular revision. Now we have recovered whatever we have lost. So you see, if we click this contact file, it has got the information that was lost. So this is how you recover the lost commit or the lost branch if you did a hard delete. I hope that makes sense. And I think we might be ending at this particular juncture. We have covered a lot. We covered a lot, including creating branches, moving between branches, making commits in specific branches. And we spoke about the detached head state. We spoke about the reflog, Git reflog. And then we spoke about renaming branches and deleting branches. Then I think next Saturday we will start by we'll start on tracking remote branches. For today, we are ending at this juncture. We will finalize this session, which was day 2, and then it is split to day 2 and day 3. We will be discussing about tracking remote branches and going forward the next Saturday. Thank you very much for being here today. I hope we have made our day or our session very, very useful. I hope that you will be able to actually practice on your own. Remember this simulation site or the simulated environment where you can make use of this platform to exercise or to practice the skills or the concepts that we have explained. In order for you to be able to know whether you have trapped the skills, you can come here so that you can visually see what is happening. But I also understand that you can use your local computer and your tracked directory to practice everything that we discussed today. Next Saturday, we are going to start by explaining how can we interact with remote branches. And when we say remote branches, we mean any branch that is not in our local tracked repository. How are we going to track that branch and the methods and everything? So we will have a lot to do. I insist that you come on time. Just invite a friend so that we will be in a good number. Haya maarifa hayatakiwi kubaki kwa mwalimu, yanatakiwa yafikie watu wengi zaidi. So I believe that you will invite somebody if you love them, because the skills are rare, but they are available freely. So don't be greedy. Make sure that you invite somebody and God will bless you. Thank you very much for coming. This very video that we did today will be available very soon, maybe tomorrow or the day after tomorrow. Everything will be available. So please let us meet there. Thank you very much.